Hello, PLMS Tigers. Today we're going to be working with solving linear inequalities. Our ICANN statement for the day is I can graph a linear inequality on a coordinate plane resulting in a boundary line and shaded half plane. For our vocabulary for today, linear inequality just means it describes a region of the coordinate plane that has a boundary line. You know what an inequality is. An inequality is a statement that uses less, greater, less or greater than or equal to. And in this case, we're talking about not an equation, but an inequality. Solutions of an inequality are the coordinates of the points that make the inequality true. So just like when we're solving an equation, the solution set for an inequality is going to be those points, that ordered pair that makes the statement true. A half plane is the half of the coordinate plane that is the solution of the inequality. So the coordinate plane is going to be divided into two parts. One part will be the solution and the other will be the non-solution. So the half plane tells us the solution. When using a less or greater, make a dash boundary line which states that the line is not part of the solution. So in other words, when we have a statement like x is less than 3, and when we graph that, we would do something like this. We use an open circle, which tells us that 3 is not part of the solution and that we are moving then to the left. So anything less than 3, but not including 3, is part of the solution. Well, with an inequality equation, it's not actually an equation, but it's an inequality statement, then we're going to be working with a dashed line instead of a solid line. When using a less than or equal to or greater than or equal to, make a solid boundary line which states that the line is then part of the solution. So using this same example, we do s is less than or equal to 3, then we would make a solid point on the 3 telling us that 3 is part of the solution. So in the case of an inequality equation, then we would just use a solid line rather than a broken line. So that's going to be the difference in terms of what they look like. Determine whether each point P is a solution of the linear inequality. So on this example, all we're trying to do, this is what we're concentrating on. We've seen equations looking like this, like y is equal to negative 5x plus 2. Looks like it's in slope-intercept form. So we're just going to go with that, but this is an inequality statement instead. And we're just going to substitute in the 0 and the 2 to see if it does make the statement true, in fact. So we know that 0 is x and 2 is our y. So we have 2 is less than or equal to negative 5 times 0 plus 2. Excuse me, so we're just trying to see if this statement is in fact true. 2 is less than or equal to negative 5 times 0, of course, is 0 plus 2, and that is a true statement. Therefore, the ordered pair 0, 2 would be part of this solution set. So we say true, yes, it is a solution. So you just simply use substitution to see if it works out. If, of course, that statement was false, then it would not be part of the solution. Choose the linear inequality that describes each graph. We're going to come back to this afterwards. This is supposed to be at the end. Okay, so let's talk about that. This part specifically is for a part in your homework. Oh, no, it's not. I'm sorry. I was looking at the last slide. Choose the linear inequality that describes each graph. So choose the line that describes each graph. Blank, the line is greater than. So what we're looking for in this is if I have a dashed line or if I have a solid line. The question is, if we're looking at the area above that line, then is that going to be above the line is going to be greater. So that answer then is above. In other words, if we were below the line, then we would be less than that particular inequality line. Don't use less for left and greater for right. Instead, choose a, and you might hear the vocabulary, you might hear checkpoint, or you might hear test point. So in other words, sometimes like if a line is perfectly horizontal. Of course, if it's above the line, it's going to be greater. If it's below, it's going to be less. But if the line is moving at any kind of a slope that is questionable, then you can always use a test point. And a really good, easy test point is 0, 0, of course. Try to use 0, 0, but only when the line does not run through that point. So in other words, if the line runs through the origin, then you can't check you can't use 0, 0 because 0, 0 is actually on the line. So as long as 0, 0 is not on the line, then we can use 0, 0 as a checkpoint. And you're going to see me using that today. Shade on the side of the line that makes the inequality true or false. What do you think there? Of course, we're going to shade where it's true because the region that's shaded is going to be the solution to the inequality. Graph each linear inequality. Hint, if the equation is not in slope-intercept form, change it to be in the form y is equal to mx plus b before graphing, or you can graph in standard form when the coefficients go into the constant easily, and we'll have an example of that. So let's get started with number 1. It just says x is less than negative 3. So if x is less than negative 3, we are on a coordinate plane. And if x is less than negative 3, then we are at negative 1, negative 2, negative 3. So the first thing I have to consider is what kind of inequality sign I have. And what's that going to do to my line? Is that going to be a solid line or is it going to be a broken line? Well, I know that if it's less than, then that's telling us that that line is not actually part of the solution. So I know then it's going to be a broken line. You will need to use a straight edge. So if you don't have your straight edge handy, go ahead and grab that. I'm going to use this green broken line because it'll already break it for me. And we're going to just graph it. Is it important if it's solid or broken? Yes, that's sort of the point of what we're doing. We know that negative 3 is the boundary, and then the other part of this statement says that it is less than negative 3. Well, we know as far as the number line is concerned that negative 4, negative 4, negative 5, negative 6. Of course, those numbers are less than negative 3, but we're going to just kind of go with what we talked about before, and that is just using a test point. In my test point, if I use 0, 0, which is the origin, right now we're trying to determine which side of the broken line should I be shading on. Should I be shading on the right side of the broken line, or should I be shading on the left side of the broken line? So with 0, 0, this all we have is x, so all we can really use is this 0, which is x. When we substitute that in, then we have 0 is less than negative 3. Well, of course, 0 is less than negative 3 is a false statement. So here's the thought process. Here I am at 0, 0. It is false at 0, 0. So should I shade on that side of the line? No, I should shade where the statement is true. So then you're just going to pick up your pencil and you're going to shade on the left side of negative 3. So what does this mean? It means that every point that is to the left of our broken line, remember again, x is less than negative 3, every single point to the left moving on for infinity, all of those points then make this solution true, and that's how you leave it. Make sure you check 2 things before you go to your next problem. Is your line broken or solid? Well, it's less than, so that's going to be a broken line. If it was less than or equal to, it would be a solid line. And then, of course, we shaded to on the correct side because it makes our statement true. So that's just a good start with our simple inequality. Number 2, y is greater than or equal to 2. Y is greater than or equal to 2. So now we're talking about our y coordinate. And if we're thinking about it in terms, I've talked to you guys about this before, you can always, if you're not really sure which direction the line goes, y is greater than or equal to 2 tells us that we're talking about 2 every time. So you can just randomly put in numbers for x. That's just one way that I think of it. So if you know what y is greater than or equal to 2 looks like, then we're talking about, here's our origin, 0, 1, 2, and then this time it has to be a solid line. How do I know that it's a solid line? Because, I lost my tools. It has to be a solid line because y is greater than or equal to 2. So if it's greater than or equal to 2, we're talking about a solid line. 1, 2. Oops, see, that's too thick. Way too thick. Let me just use this here. And I'm off. Not bad. And then make sure we have arrows on the other end. I didn't say that on the other one because the broken line was already had arrows for me. So y is greater than or equal to 2. So that's what our line is going to look like. So you can kind of see how that goes along with the table of values as well. You don't have to do the table of values. It's just a way of remembering, is y is greater than or equal to 2. Is that perfectly horizontal or is that perfectly vertical? That's the purpose of that. Then y is greater than or equal to 2. Well, instinctively, we're going to think, okay, greater than or equal to 2, that's going to be above the line. But we want to make sure that we're doing this correctly, so we're going to use a test point. And once again, we can use 0, 0. I know that I can use 0, 0 because 0, 0 doesn't go through the line. 0, 0 is our test point. We're talking about this 0 because that's our y, this is our x. When I substitute that in, 0 is greater than or equal to 2. Is that a true statement or a false statement? No, well, that's a false statement. If it was true, I would shade where the 0, 0 is. But it's not a true statement, so we have to shade then, of course, above the 0, 0. And I'm going to use highlighter if I can. Oh no, my tools are gone, so I'll just use a pen. And we're going to shade above the line. That tells us that every ordered pair that is above the line is a solution to this inequality. Before we move on, we're going to check. Greater than or equal to, that tells us it's a solid line. And then we're above the 2, which would be a solution to this statement. Now we really have an inequality that looks almost like slope-intercept. The only difference is that it's greater than or equal to rather than just equal to. So we're going to treat it the same way. We're going to pull out from the equation y is equal to mx plus b. Just a little review on graphing equations. So our b is 1 and our m is -2. So our slope-intercept is 1. And then we've got a slope of -2. That means down 2 over 1, and repeat that process. I know right away that my line is going to be going down because it's a negative slope. From here, I go up 2 and then back 1, and repeat that process. Makes it a little easier to graph when you have more points. The first thing we have to determine is, do I have a solid line or do I have a broken line? Well, it's greater than or equal to, so equal to means solid. So I'm going to use a solid line, use your straight edge, put arrows at either end. The next step then is to use a test point because we have to determine which side of the line we're going to shade on. Can I use 0, 0? Yes, it's close, but it actually doesn't go through the line, so it's okay to use 0, 0. Whoopsie. Oh, no. Okay, we're back on track. So I'm going to use 0, 0 as my test point. When I substitute that in, I've got 0 is greater than or equal to -2 times 0 plus 1. So we're trying to find out if this is a true statement or a false statement. So I've got 0 is greater than or equal to 1. That is a false statement. It doesn't always end up to be false. I know in all of our examples so far it has ended up being false, but it doesn't necessarily, that's just coincidence. It's false, so when it's false, then we don't want to shade where the origin is, we shade where it is true. So at 0, 0, it's false, so don't shade on that side of the line, we're going to shade on the other side of the line. So every coordinate, or every ordered pair that's to the right of this line is part of the solution. So before we go on, we're going to check greater than or equal to, that means a solid line because it's equal to. That is part of the solution set, and then we used a test point to check to see if which side of the line to shade on. In our last example for today, I noticed that this equation is in standard form. I could put it in slope-intercept form. We're very comfortable with that, but we also know how to graph in standard form. Remember, ax plus by is equal to c. And so this one's a nice problem because the 3 and the 2, let's be more specific, the -2 go into 6. So I call that a mini table of values where I do x and y, put a 0 in for x, put a 0 in for y, and that's going to be easy to figure. So if I substitute in 0 for x, then I need -2 times something is equal to 6. That's going to give me a -3. And then if I use 0 for y, then that is going to make my x 2. And if that's confusing to you, you can always just do the entire equation by substituting in to calculate your y. If you can do it in your head, some of you are probably getting pretty good at that, then that is acceptable as well. Just make sure you get those points accurate, because if you don't, then you have 0 chance of getting the problem correct, and we don't want you to miss it on the first step. So 0, -3 is my first one, 1, 2, 3, and 2, 0. Okay, now we have to determine what kind of line we're going to use. Well, this says greater than, so greater than means a broken line. The equal to is what makes it solid. So if it's greater than, then I'm going to find a broken line up here. Not too bad on my first attempt. So I know it's a broken line. The arrows are already there for me if they're not going to be for you, so make sure you put those. And then we have to determine which side of the line we're going to shade on. Okay, can I use 0, 0? Yes, I can use 0, 0 because it's not actually on the line itself. And so we want to use that as a test point. When I substitute in, got 3 times 0 minus 2 times 0. We're trying to find if it's a true or false statement. And we've got, guess again, 0 is greater than 6. Just happened to be false. 0 is not greater than 6, so it's a false statement. Do not shade where 0, 0 is, then shade on the other side. If it ends up that the statement is true, then you shade on that side. So we have a broken line because it's greater than, broken if it's greater or less, and then we've determined which side of the line to shade on. This part is just for the last part of the homework that is on page 408, numbers 34 through 36. So this is just guidance if those problems are assigned to you. Write the linear inequality shown in each graph. So in this case, you guys are going to be given graphs, and then you have to write the inequality yourself. So determine these are just hints to get there. Determine the y-intercept. If there is no y-intercept, find the x-intercept. Number 2, find the slope of the line. That should be no surprise to you. And then number 3, substitute x or y and m in the equation to determine b. So you're not going to know the b. This is just a reminder of what slope-intercept form looks like. So once you know x and you know y, then you can solve for b. Write the inequality in slope-intercept form. I hope you've enjoyed learning about solving linear inequalities.